sharing it now. So you should see. All right, let me just make sure. Give me a moment. All right, I'll be right back. Let me just.
Okay.
Hi, Andy.
Yeah, hi, George.
How are you?
Yeah, very good. Very good.
Cool.
Yeah. What I will make some transfer to Emmanuel right after I've not stepped out today. Yesterday I'm going late, so
Mm.
please bear with me. I'll let him
No,
do it.
that's fine. That's
Okay.
fine. Yeah,
All right.
great. Um, let's
Hi,
see
Cyril.
here.
Yeah. Hey, hi. How you doing? Well,
Yeah, good. It's been a while.
yeah. I know. I've been on low profile. I had this real bad infection that ear
Oh,
infection.
yeah, okay.
Uh, and it has not been a smooth ride at all.
Yeah,
So,
sorry. Sorry for that. Yeah.
Guys, just give me a minute. I'll be right back. Okay.
all
Okay.
right, no problem.
Let's see, Emmanuel. Let me call Emmanuel.
Yeah. So that's what I've been dealing with. But
Oh, I see.
yeah, I, I it's just now that I kind of I can tolerate the phone a little bit. Earlier on,
Yeah.
I would not even want to talk to anybody.
Yeah. Yeah, I tried calling you a few times, but
Hmm.
yeah, couldn't get through. I was telling Emmanuel about that. I didn't know you were not well, so I'll just.
Yeah, even Stone did not even know.
Oh,
I
okay.
All right, guys. Sorry for the hold up. I see Nana joined us. What about Emmanuel still? All right, give Emmanuel about 2 minutes. Okay. Can everybody see my screen okay though?
No, not yet. Let me see. Oh,
Yeah, I can see your screen.
You can see like POC people,
Right.
the
Yeah,
all right,
I
the
got
notes
it.
you've been using. Okay, cool.
how did I enjoy the last time? Um,
How do you do what?
I said I don't even know how. I don't remember how I joined the last time. think I went back to think my email. Let
Mm.
me see my.
Okay. All right. We'll start. I pinged Emmanuel to join. He hasn't responded yet, so we'll start and then he will join. All right. So as promised, this is going to be a bonus session, and it was necessary from two perspectives, right? One is the PL core material was a lot more uh, than we could cover, right? And as we all sort of agreed that you guys needed more practice in terms of the queries, and um, it just didn't make sense to just go through a ton of material that you would probably not find useful to get a job right away. Once you can get a job, most of the other information you can research it. And like I said, I remain available for consulting in different capacities. And I'm going to do my very best to one help you prepare for your interviews, and also once you get it, um, you know, with the appropriate arrangements, helps you, be a smashing success in your role. So, but perhaps more importantly, you really have to understand the concepts so that you can actually see the benefit of this beyond just even getting a job, but you can actually see this as something that you could do for yourself, create a business out of it, or become a teacher, and what have you. So that's why we ended up going this route. That we didn't really work on any project per se. So the structure of today would be sort of go over all the key concepts we've discussed so far, right? Um, Obviously, after we've reviewed the homework, and then um, sort of quickly see if you guys have any special topics you want us to discuss. And if you don't, then I would immediately try to spend at least an hour, right? Ideally by around 12:30, 12:45, switch to showing you a couple of things related to applying some of these concepts with the project. Can everybody hear me okay?
Yeah, I can hear you.
Yeah,
Okay,
I can hear you.
good.
Uh,
Yeah. All right. So I see the recording is ongoing. That's good. I sent out the artifacts for session 6 and 7. Did you guys get it?
yeah, I got I just saw it on my email. Yeah.
Okay. I don't think. I mean, Andy, I sent it to you, Andy Mankata at Yahoo. I did not. That's why I actually asked for your Gmail. I don't know why. Even though I've sent you an invite, Gmail still doesn't link your email address to my. So now that I have it, I'm going to actually send you a test email,
Okay.
uh, just so that it records that you're somebody in my circle, that it should automatically self-complete when I'm trying to send a message. Okay. Um, so Andy, I know you wanted an assignment. You wanted to discuss it. Did you? How did you do on the assignment?
Um, I did. I've done the first part. I mean, and I can let me forward that to you and
Yeah,
see.
send to me, and we would quickly discuss that. I
Yeah.
think Nana missed quite a few sessions, so
Okay.
um, okay,
1 second. I'll forward that.
sure. Let me present. Something funky with this thing. Anytime I try to present my screen, it gets into an infinite loop. Don't know why it does that. Okay, there we go. All right. So while Phil says the assignment, so while Andy sends the assignment, what the assignment was about, for the benefit of actually both Nana and Phil, we've learned about functions and procedures and packages in the PL/SQL world, right? Where with SQL, when we've learned SQL where you can write a query, right? And the query, you write it and you get some report, some output, right? But that's all there is. It's just an output that you see on a grid, and you can save the result into maybe Excel or CSV or something like that. So, we're used to, if I do select star from HR.employees, right? And around that, it's going to give us some results, right? And this result, you can then right click and export, right? If you're using SQL Developer. And then in export, it gives you a bunch of options. You can export as an insert statement, as a fixed length, JSON. These are all different data types. They have CSV, Excel, a whole bunch of stuff. So for the interest of this, maybe I'll just pick, I don't know, let's say CSV, right? And the CSV would have a bunch of options where by default it's comma separated. And it will give you a header, right? If you want to export the headers. And let's say, I call this file list of employees, okay? List of employees. And then I click next. Now, if you're doing this in Toad, it'll be a little different. Now, it exports my data out. My data was exported to some location. What did I call it? Right click. You don't see what I'm doing, but I'm just navigating to my C drive users, and then the file that I just exported is the list of employees. And the contents will be there. So let me show you. Are you guys able to see my screen still?
No, I'll just have to hang up and use my laptop.
No, I stopped sharing. Can you see now?
No. I'll just kill my phone and then use the laptop. It's not allowing me to connect because I have a response that I'm already in the meeting. Okay. But I want to use my computer. So.
Okay, and just turn off the microphone on one of them so they don't get the feedback, right? So
okay.
Right now, so I exported it out. Do you see this file, list of employees? That was the output that I exported out. Okay, and this file is something that you can then open up. It's a regular CSV file. For me, this is just a CSV file that you can open in Excel or whatever tool you have, and I have the list of employees. Okay, is this part clear?
Yeah.
Okay. So the idea of it is, I still continue to monitor for an email from you, Andy.
Yeah, I send the assignment and
got it.
Gmail to your Gmail.
Yes, just got it.
Right.
So I'm just trying to get to this point of establishing that when you write a query and you get an output, right? That output you can save that output into a file, right? And that process that you're doing is all manual, right? So you go to SQL Developer, you type some query, you run the query, and the result set comes back, right? And once the result is back, you can save it. Now, beyond that point, what is the usefulness of that query, right? It's just some something that it's transient, like it's done, and you do it once and that's it, right? However, that's not what we want in sort of in a professional setting. That if somebody spends some time to write some query and the query is working, we don't want to lose it. So typically, once you've identified a query and you've worked on it and it's working, you need to find a way to make it permanent, right? To make it permanent means you have to transform it into such a state where it would be useful for other people, or it can be part of some regular automated process that you'll be running. Okay. So then enter PL SQL. So with PL SQL, you are able to embed, right, a query that you've developed into some system, right, within the Oracle, into a subsystem within the Oracle infrastructure, where that query becomes permanent. Meaning, a query that you run that says select staff from employees, you can then, if that's, let's say that's what you develop as a high intelligent solution to some problem, you want to save it. And you want to make it permanent so that every user within the Oracle database or only or privileged users can run that query. Then yes, PL SQL gives you tools to do that. We talked about those tools as either a function, a stored procedure. Those are the two main sort of utilities that allow you to do that. And then you can combine a bunch of these functions and stored procedures within a package, right? And a package meaning it's almost like think of like a USPS. You are shipping a bunch of stuff, right? And you put it in a box, you package it up. The package is just nothing but grouping a bunch of related things together, right? And then Oracle will know that, okay, Andy or Nana or Cyril has written a bunch of functions and procedures for some project that they were working on, and they want to tag it with one global identifier that says this is in reference to this particular project. Okay. Now, if some of this sounds too foreign or too, if it's too foreign, I'll go through the tutorial a little bit more. But for now, Andy has sent us his solution. So I'm going to bring that up and share SQL developer. And let me save. Okay. All right, so it's in my downloads. So I'm gonna go to open. Yeah, all right. So when we had talked about it, right, the idea was we want to be able to create a function that would, or the assignment was, if let's say we've come up with some query, and that query gives us the ability to identify, right, for a given department, what the average salary is. And we want to be able to reuse it, right? How do we put it within a function, right? So, Andy, you want to talk us through how you approached it and the challenges you had, and then we will try to finish it up together.
Oh, okay. Actually, I mean, the function, is it the syntax or the format? I just inserted the select statement from our previous assignment, and then so I'm naming it as AVG cell,
Right.
and we expected you said we should have a parameter or provide the department ID, and then it will give us the average salary per the employee. I mean, if that was if I understood the question right.
Right.
So
Mm-hmm.
So I brought in the previous from a previous assignment, the select statement that we had. Showing all the average, the ratio, and all that. And so when you run this, it should ask for the department ID, and then you provide that, and it will give you the result set.
Okay. When Andy was speaking, what did you guys see on your screen? Did you guys see the SQL developer, or you saw like some grainy?
The grainy interface.
Okay. Right. So basically, the way it works is if somebody is talking, then that person will show up, and then you won't see the screen, right? So what I'm going to do is present this to everyone. I would have to figure out a way to set it up so that when somebody's talking, it doesn't take away from the screen. Okay. What I'll do for now is there's a chat window, right, for the session. So if you have a question and you want to pick it up, hey Cyril, we can hear you. Cyril, are you okay? Cyril. Okay.
Yeah, hello.
Yes, we can hear you.
Yeah, hello.
Yeah, Cyril, talk. We can hear you.
Yeah.
Okay. Can you hear us, Cyril? Cyril, can you hear us? Hello, Cyril. Can you hear us? Cyril, can you hear us?
Yeah, I can hear you.
Okay. Okay.
Yeah, I was trying to get my how do you call it? My wireless thing on, but I heard you for a while and then I just disconnected, so I didn't know what was going on.
Okay,
But
that's fine.
So George, so my problem with this is when you run it, it asks there's a dialog window that pops up to ask for the department ID, but it doesn't run the result set. Like we don't have it. It
And
doesn't.
that's fine. I see. I think I see where your challenge was, and we'll talk about it. Then that's why we had the bonus session, and also just to make sure that folks understand this. So there is a general structure that you use to write functions, right?
Yeah.
And let me share with you the documentation that we've been using. Then we would follow from there. So the link to the documentation we've been using, as you guys are familiar with already, is a publicly available link that I really like. So effectively, what we've been going through is that, as I established in the beginning, right? If you have a query that you write and the query gives you results and you save the results, it's a temporary thing. It's done and it's gone. It cannot be reused easily. Anytime you want to run that query, right? Somebody has to log into SQL Developer, and then once they log into SQL Developer, we would show them all the other things, right? They can they can type the query in the SQL Developer, click execute, and the results will come back. What we're doing is that given a SQL, we can put a wrapper around it. And that wrapper would make sure that it becomes a utility or something useful that you can call repeatedly, because the very essence of programming is to reduce a lot of to stop reinventing the wheel, so to speak. So if I have a query and that query gives me an output and is good, let me put it in a situation where anybody else within the department who is privileged can just call it and it'll give them back the outputs, right, that I have. But oftentimes when you write a query, it gives you a whole bunch of rows, right, a bunch of results. You may not be interested in that, and the requirements could be, hey, can you, this query that you have that shows me for every department and the average salary, can you set it up in such a way that if I call it and I just give it a department ID, it will just give me back the average salary? Okay. So I'm going to share my SQL Plus window. No, sorry, the SQL Developer window. And then we would, I'll walk you through these steps again. SQL Developer, share. Okay. So Andy, I will come back to your spreadsheet, your query in a minute. Here's what I'm trying to establish. So from the previous sessions, right, we've done things like, let's do this on alias, and we say, okay, e dot department ID, and we'll say AVG, right, as AVG salary. Okay. I'm going to write a simple query that would e dot department ID. This query would simply return the average salary within the department. It's given us this, right? So we know department 100, the average salary is this. Now, again, for purposes of this, so that it displays nicely, I'm just going to round this to 2 decimal places. And when I run this, it's going to give us, for this department, this is the average salary. For this department, this is the average salary, right? So the point I'm saying to you is, this query that I've written, if I run it and SQL Developer shows this result, it's temporary. The moment I close out my SQL Developer, it's gone. Now, there are multiple ways to make it permanent. One of the dubious ways of doing it is, you save this file, right? Title 10, but let me just give it a good name. So I'll save this file as, SQL tutorial, and I'm going to do testing function with SQL. Now, right? And if I save this testing function at SQL, while we haven't done this because it's sort of scripting, I can call this function in SQL Plus and it would work. Now, traditionally, the way you would do it is you would start a PowerShell script or a Python script or something like that, and you call SQL Plus. We're not doing that now, right? Right now, what we're doing is we're saying that we've saved this file. And the point of it is that if you've saved the file, you can call it and it will execute. So here's the output, okay? How do we make this permanent? How do we make this permanent? One way to make it permanent is to use a stored procedure or a function. Now, how do you determine whether to use a function or a stored procedure? In the last 2 sessions, we've talked about if your idea or the objective is to get an output that you can use, then you want to use a function. Procedures basically consume functions. right, to do a bunch of stuff. So that's one way you can think of them. A function like sum will take two inputs and give you an output. So if I have a query that gives me a department and the average salary, right? In this case, there are 11 rows. And I want to transform this so that if I give you department ID 100, if I call the function that I'm going to create and I give a department ID 100, it's going to give me 8,601.33, right? Then I would have to create something like this. Let me put this side by side here. Okay. The general structure of creating a function goes like this. Create, and this is in the documentation we've been reviewing, right? So it's create or replace, meaning that if the function already exists, right, then we are going to replace the definition. But if it does not exist, then create a brand new one. So I'm going to create or replace a function. Okay. And here, Andy, I hope you see where I'm going with this, that your approach to it is that you pick some query and you're trying to put it in the what's it called? You're trying to put it, you're trying to put the query within the function. However, the structure is a little different, right? You have the create or replace there, right? But then you have to put, after this, you'd have to put function. And then you can give it the name that you want to use, right? So generally the structure would be like, say, oh, for convention, teams would say FN underscore, right? Function average salary. Okay. So you give it such a name, and then you would then say, these are the input parameters, right? This function is going to take a department ID, which comes in as, for lack of a better, let's say it's going to come in as a number, right? That's the structure that they give us. But very importantly, it has to return something. So this function will return a number, right? Because it's going to return to us the average salary, and the average salary is a number. And then you say is. So now you're about to define what this thing is actually going to do, right? Then you put the structure of begin, right? Now, obviously, there is some logic that you have to do, right? Which is, if you say, all right, I have this function and it's going to return a number. How do I return what number? Where is this number, right? How am I going to return it? Within within the structure of creating a function, you would have to allocate some memory, right? That you will store that value in. So if, for example, we say, variable average salary to return. So I'm going to return this, right? And this is a number. Okay. Then structurally, you actually want to put it here, right? You want to say, this is something I want to return. Then what you do is, now here I'm gonna bypass this query that you put and put the one that I gave here, because really that's all you want. It's just a very simple function that will do, will do this, right? It's a bit of an overkill, right? So you would do something like select into this variable. I select into this variable. Brackets here and delete this. Okay. Where department. So I use my convention of DT, where DT dot department ID is equal to whatever the user supplied. So as a general principle, you actually want to, I like to say, follow this convention of, if this is an input parameter, you say P underscore, right? That's sort of the structure you see in some teams. So functions will start with FN, and then parameters will start with P underscore, right? So then you use that here. Okay. Hey, Manuel. All right. So then we just had Manuel just join here. So the point is that you have this query, and when I run, just highlight the query, it gives you this output. For the department ID, this is the average salary. So I can make this a temporary expression, and let me just format it for the purpose of making sure things are good. Then I can say, well, if I have this output and I want to make it permanent, is there a way for me to pass this parameter into it, right? Understand that the structure or the approach we're doing here is not that different from if, let's say you had it as an inner query, DT, okay? And you say select DT dot star from, okay? That's all I'm really trying to point out here. Select DT dot star from is equal to this. And then here I can say where department ID is equal to the 100, okay? And this will give us just the department ID 100. So this 100 is the input parameter, is the one that you're going to supply into the function, right? And then once the function recognizes the 100, it's then going to return to you 8601. That's the overall objective here, okay? How you get to that point, right, is, again, you have this query, right? Let me just format it a bit. And this query is doing all this beautiful stuff, right? All I'm changing, the two key changes here is where DT, the department ID, in the below one, I said equal to 100. In this case, it's a dynamic thing. It's whatever the user supplies. It's, it will take, if it's 100, then it's going to run this query and pull the one which is 100, which is 8601, and return that value. Now, how do you return it? Okay. Now, let me show you in the doc. Well, do I have it? Oh, actually, you know what? You guys can see this side of the screen. Let me share this. And I want to draw your attention to that section of the documentation. We'll come back to this. Stop. Share. And let's share this guy. Okay. When we were creating a function earlier, right? This is a format I just followed, right? Create or replace function, function name, and then you list the parameters. And you say is, then you put your variables, you know, in this case, the output. I say begin, and then you end the name, right? And this is where you put your code. The key is that you have to return a value because functions return values, okay? Yeah, and did you see the structure here and how I'm making the adjustments to your solution? Andy, are you there? You know what? I think I muted Andy.
Yeah.
Yeah, Andy, can you hear me? So, see what
I can hear you.
Yeah, Judge, I can hear you.
okay. I'm muting you guys because so that when you talk, it wouldn't get a blank screen, right?
All right.
So if you want to say something, so let's do it this way: mute yourself, and if you really need to say something, you unmute yourself. Because what's happening is the moment you talk or you breathe and the microphone picks it up, then it switches the screen. So if you all can mute yourself and unmute yourself when you want to say something, it would be much better. Anna, can you mute yourself? Emmanuel, can you mute yourself? Andy, can you mute yourself? Emmanuel, can you mute yourself? Andy, can you mute yourself? Okay, we will just you know stick with that approach for now. I don't think anybody's interrupting us now. Okay, again, if you need to say something, please just unmute yourself and talk. Okay, so that the recording will consistently have the presentation material on. Okay, so what I'm trying to highlight to you is that you see that you have create or replace. It says function, then the function name, followed by the list of parameters, then is, then you put whatever variables or you know that you need to use, right? And then you declare those, followed by begin. Then you put a bunch of your code, which is going to do all that beautiful stuff. And then once that is done, you return. Okay. Is that okay? Are you there? Hello?
Yeah, I can hear you.
Okay.
Yeah.
So with that said, I'm going to go back and share. Okay, somebody asked the question. Let me check. Let me. Okay. Emmanuel, you commented about my glasses, huh? Yeah, I do wear glasses time to time. That's one of the side effects of the of this career, though. Actually, you still had the screen for quite a bit. All right, so going back to the solution that we're working on, right? If let's say we are returning the average salary, right? So remember that here, right? This is a query that you give it an argument of 100 and it will run this inner query and it will apply a filter of 100 on it and it will just give you this. Now, if I just wanted to return the salary and instead of It won't just give me it won't give the department ID. It will just return what? 86. Sorry, did I type correctly? Average salary. dt.average salary. Then it will just return what the average salary was, right? Again, if I change this to 20, I don't know if department ID 20 is this, but let's say 20, then it gives us the department ID is average salary. For department ID 20, the average salary is 9,500. One more example, department ID 30, as you can see, it's 4150. So if I change this to 30, this query should give me 4150, right? That's the average salary. So now, again, we keep typing this, and I keep manually changing this, which is really not useful if you're going to have a program that's going to run by itself, right? Because if a program is going to run by itself, you cannot be going in and typing these into it, right? You need to set it up in such a way that the program will be dynamic. And the way you make it dynamic is you create a function. I'm creating this function, right? And the structure of the function is create or replace function. And I advise that you use fn underscore to prefix all your function names. This is also faced by the same 30 character limitation. So you want to use fn underscore avgsal. Don't use anything more than 30 characters because Oracle will reject it. And you're going to say, well, it's going to take this, my function will take a parameter. And the parameter is just the department ID, right? And the function, the job of the function is to return a number. It's going to return a number. And now you're going to put the logic in there to do the beautiful stuff. So logically, you're going to say, what I'll do is, just so that I won't get into that part yet. So I'll declare a variable, right? This matches to the variable declaration section within the documentation, right? Which says, after you've done your create or replace, and you're given the function name, and you specify the parameters, and you tell it what it's going to return, and if is a requirement, right? You're just telling the database, this is what I'm going to do, right? I'm creating a function, and it has this definition. The first thing is you declare what variables you're going to use. In this case, there's only one variable that I can think of that we're going to use, which is the variable that we're going to return, right, to the user. So really, once I declare that variable, I'll say, okay, return this. I want to return it here. Okay. Now we have to put a lot of decoration and dressing into this, but for now, let's just leave it as it is and say, all we're doing is we're saying to you, we have this query. Now I want to highlight this query. The output is what we've been working with. It comes back with 11 rows. For each department, it shows the average salary. What we want this query to do is to take this parameter of the input department ID and return to us the average salary. Okay. So I'm going to do something here to highlight this point. Whenever you're creating a function, remember a function is an object, like a table, a view, an index, a sequence. These are all objects. So it has to belong to a particular owner. Now, since I'm logged in as a system administrator or system DBA, I need to specify who actually is going to own this. It's a terrible idea, a very bad practice to log in as a DBA and start creating functions for business. You should always create these functions and let the owner be the particular schema which is doing it. If you log in as DBA, you have access to every schema, which is the danger, right? Now that I'm logging as DBA, sysdba, I can put HR dot here. Now, if I was logged in as HR, I could do it, I don't have to prefix it with this. But generally, in any organization that you work in, when you're writing code, you should always use fully qualified names. Just as when we're creating this table, I say, select staff from HR as employees, you should always use fully qualified names. So this function should also, have a fully qualified name, HR dot, right? Any questions before I proceed further? Okay. If you have a question, please unmute yourself and talk. All right, I presume everybody's good. All right, so now we have sort of the definition of our function. So if we have this, look at the structure. We've declared that this is the variable we're going to return. Every programming language you deal with follows a very similar structure as this. There will just be a few sort of keyword differences, but every programming language you deal with will be like this. When I say programming language, I'm talking about Java, C#, .NET, C#.NET, right? Python, all of them follow these, the sort of this approach. You declare a variable that you plan to use later. In this case, I'm declaring a variable and I'm going to select the average salary and put it into that variable. The way you use a variable in PL/SQL is if you want to use it, you put a colon in front of it, right? This tells the actually no, in this case I don't have to use it here because we're not prompting the user for it. If I was prompting the user for it, I'll put a colon. But the way you assign a variable is you put a colon. But if you're going to use it, you don't actually have to do that. You basically say the average salary this, and then you select this average salary and put it into this. After you've put it into this, you can then return it at the bottom. So typically what you do is you put comments in your code and say, now return the average salary. Okay. Caller. Let's say to caller, right? It's better to say caller. It's a calling program. Okay. So to put some note here, we're gonna put run query to fetch average salary for all departments, and then apply filter to only so that we only return the average salary for the input parameter. The input parameter, this guy. Okay. So this basically means that we've written a program, and that program will do this. Now, this is sort of what they would say the meat of the program. So now, if I run this F5, if there's no issue, it creates a function, right? This is function. This has been compiled. If the function has been compiled, then in theory, I could say select HR dot this and pass in 100 from dual. And then with that, it says, well, it's in an invalid state, blah, 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 blah. Okay, I said, okay, why are you in an invalid state? It says, you are checking, there's an error at line this.
Yeah, it
Yeah.
looks like line 22, the function name you're using there, it's
Oh,
line,
yeah, so we
yeah,
changed it here, right?
yeah.
Thank you. Thank you so much. So let's do this again. Now, this is where, if you're developing, this will happen quite a bit. That's why the creator replace is very important, right? Because it created it, but now it says, okay, I have a mistake. What do? I highlight it and I hit F5. Then it will go in and it would create it again, right? Where has replaced it. Now, the output here says it's compiled. So what you can do, right? In fact, just to highlight this thing that we've been sort of doing, let me snap this to the left side of the screen. I would expand the sysdba, and within sysdba, we go to the other users. And other users, you have HR, right? HR is the schema that we created this in. So if everything is good, now HR should have a function called this guy, function average user. And you see, it's right here, right? You see it? That we've created a function that belongs to the HR schema, right? Remember, HR schema has the tables, employees, countries, departments, and all that. We've been working with that, right? And now we are getting richer in terms of our SQL knowledge. We have queries we've written, and we want to be able to reuse these queries. So we've created a function that is wrapping itself around this query that we know, which will give us for any department, the average salary within that department. Okay. The beauty of this is when you do it that way, it's actually very fast. Oracle actually compiles it, and it saves the fastest, well, I won't say the fastest way, but it saves to retrieve that value for you so that you can always reuse it. It's almost like if you go to Dunkin' Donuts, right? And you, I don't know, it's a very good example, but you go to Dunkin' Donuts, and if you've pre-ordered your coffee or donuts, whatever it is, on the app, if you have the app, you go in there and they just give it to you because somebody pre-fills it before you even get there, correct? Participation, is that correct? You get extra credit if you participate. Please, is it correct? If you go to Dunkin' Donuts and you pre-order, they give it to you right away? Okay. So what does that mean? You're saving them, you're saving you and them some time. So by the time you leave the house, you know you're going to get it, you order it. As soon as you go there, there's no interpretation that has to happen, right? You go there, you show them your ticket, boom, you pick it up and it's gone. I'm supposed to go in to join the queue, talk to them and figure out what you want before they fill it and they get it for you. That's a longer process. With functions, once you create a function, Oracle internally says, okay, this is a query that the user will be running a bit, so let me figure out the best way to do this so that anytime they want it, I'll give it to them very quickly. Right? So that's actually one of the reasons why you create functions. Beyond just encapsulating or maybe putting, wrapping something around a query that you like to use repeatedly, it actually is efficient at then saving the execution path for it, right? So it says, oh, user so and so has ordered coffee, right? And I make it for them. By the time they get it ready, they pick it up and they go. It's much faster than the user comes in, oh, looks at the board, oh, do I want this? That decision of do I want this is actually what happens when you connect to a database. It says, do I have enough memory to do this? Oh, okay, I have some memory. What do you want to do? You want to run this query? All right, let me figure out how to get the data and put it into memory. And then, oh, you want all this department and the average salary? Okay, all right, this is the average salary for this department. Now, what department do you want? Oh, department 100. Okay, let me apply the filter and let me give you the result. It goes to a lot of decisions to do that, right? But if you've saved it, the moment you connect to the database and say, give me this, boom, it's instant. It already knows that when somebody calls this function, it has to go to this side of it and get the results back to the user. Very, very, very fast. Okay. So now we have this our function. The question is, how do we use it? Okay. So if you have this function, how can you use it? All right. What was it? Let's see if everything is good. Right. So we call this function and we give it a value of 100 and it gives us the average salary. Right. Now, let's see here. Notice it took what? 0.007 seconds to come back. Okay. Now I'm going to run this thing and see how long it takes. Now, this is going to take 0.001 seconds. Someone said, well, this is better. I just ran this query. the reason why it's better is that the moment you run this query, the function, it reads the memory. It reads into memory, right? It reads the result into memory. So the user who calls it again, even though they're going to a query, this data of the HR employees is already in memory. So it's going to come back very fast, right? If you have to repeatedly do this, it's way faster to continue to do this, right? Let's try 20 to give us about the same consistent result, 0.002. Let's try 20 here to give us 0.004, right? So what you're going to see is that with this function, the first time you call it and it loads a function in memory and all that, you get an overhead, but progressively, it's going to give you time, which is going to be faster as you call it more often, right? Now, there are a few issues that we have to deal with this function, and before I get into it, I just want to make sure that folks understand where we are with this function, or do you have any questions? Andy, do you have any questions since you worked on this?
No, it's good at this point.
Okay.
Yeah.
Now, I know for Cyril and Nana, this is a little new. Emmanuel, this shouldn't be too, because you've been part of the 2 sessions, and I know you joined late, but the assignment that we gave last time is what Andy made a decent attempt at it, and I just added a bit more meat to it so that we can get a solution. Now, this is not the perfect solution. And the reason why it's not perfect is that we're not dealing with nulls, okay? We're not dealing with null at all. So let's see what happens if we try to run this query and we give it null, right? If I call this function and I say null, what is going to happen? I don't know. This is null, right? But you guys know that for the department where it's null, the value is 9,250. So why is it that when we call this function and we give it null, it comes back as null, right? So again, the point about dealing with nulls is very, very important. Because we've never handled this null here, right? We have a problem. So one way to deal with the null is you can say NVL, department ID. If it's null, let's use say 1. Let's use -1. Okay. If this is what we're going to do, right, then if I run this inner query, the null gets replaced by -1. And now I can supply -1 here, and it should give me, what did I say, department DT, oh, sorry, I didn't give it the alias yet. Then I should be able to now get the 9250, right? What I'm highlighting to you is that because we have null values, you have to make sure your query is correctly handling it so that your function knows what to do with it. So I repeat the same thing here. In our function, I say this query, if it's null, let's use -1, okay? And we give it the right alias of that. And now we can create and replace our function. It will define it again. And now we won't call it with null because we know it's -1, okay? And when we run it, it will give us 9250. So what you do in your code is that you put some comments and say, this function takes as input the department ID and returns the average salary for that department ID. If for null values, we use for now, okay, let me write English well. Department, an employee with a null department ID is replaced this is not right English. A null replacement, a null department ID for an employee is lumped together as -1. Lumped together and reported with a -1 department ID. Okay. Now you put these notes and comments because it's like, if you're publishing a product you're going to sell, you have to put the disclaimers, right? That I have this function and this is what it does. Because you don't want people to kind of do funky things. Now, what if somebody, even though you've done this, decides to call it with null? Call it again so that the function definition would then have the comments, right? And that's important because, if you create a function and you want to make sure that these comments are preserved, right, as you save, because this is saved now in the Oracle database. This thing is saved, and anybody can come back and use it. So you're going to join teams where you go and they have existing functions there, right? And your boss will say, hey, I had one guy come in, he created a function, and the function is giving me a problem. Can you go fix it, right? The first thing is you have to navigate to go figure out what the function is. And the person is trained well and did their work well, they would have put these comments within the code. Because if the code is like 300 lines or 1,000 lines, you have to scroll through to figure out what's going on, and they don't have any comments, it's very, very difficult to understand how this thing is, right? So very important for you to put your comments within your function. Okay. Now, I'm going to highlight another point. So if somebody gives you null, right? If somebody calls it and gives you null, what are you going to do? Still going to give back null, right? So one way to address that is you have to put rules within your function, which will say if a user gives me an invalid input, then this is what I'm going to do. I'm going to tell the user, you've given me an invalid input or something like that, okay? Because you never want a situation where your users are giving you bad input and you are processing them, okay? Because if you look at the documentation that we're working with, there's actually an example where they show you, right, this. So there, the example they did, I mean, I for the interest of time, I won't switch. Yeah, but if you read the documentation with the functions, I'm going to have it side by side and just make that adjustment within our code so that we see it. What they do is they'll say, if the user gave me a parameter and is null, if parameter primary is null, then in our case, we're going to explicitly return null, okay? Else, go ahead and do all of this stuff, right? And if, so and if, okay. Let's format this so that things are lined up correctly, okay? So let's run this, right? So now, let me reopen this function in SQL developer, right? So now we put in a check that if the person supplies us a null as an input here, we know we're going to explicitly return null to them. Now, you could actually choose to say, I want to return a null. I'm actually going to return a different number, right? So what that means is you could say, if the person gives me, if the input that they came with is null, I'm actually going to return negative 9999, okay? And in most systems, that's actually, you do something like this. You're going to give a very bogus number, right? And then you put in your notes that this function takes into input the department ID and returns the average salary for that department, right? I'm going to put from the HR.employees table. And you say, in that table, employees with a null department ID salaries. In that table, employees with a null department ID are lumped together and reported with a -1 department ID. Okay. Then you can say, importantly, if the calling program's input is null, the function returns -9999. Okay, and this way you are explicitly telling the function that if somebody ever gives you that, that's what you're going to return. So if I call this again, it's going to give me -9999, right? Meaning that you, the person who's going to consume my product or the function I've created, you should figure out how you get it. So if you give me null, I'm going to give you -999, and then your program should then interpret this -999 to mean that you don't know or I don't have a value for it. So you handle it however you choose to. Okay, it's a communication. Creating functions and procedures is all about handshakes between developers and having a contract that says, in this contract specification, this is what we're going to do. You give me a department ID, I'm going to give you the average salary for that department. Now, beyond that, you then have to say, if you give me an input and it's bad, right? You say garbage in, garbage out, right? So if you give me garbage input like no, I'm going to give you a garbage output like -99999. Okay. This -9999 is just my choice as a developer to report -999. It's nothing that is etched in stone. Different teams have different standards that they use. Oracle, for example, has a convention to use anything with an error code. They will start with like, I think it's like, they have error codes up to almost 20,000, right? And they all start with negative, right? So in Oracle, anytime you write a function or you write a program and there's an error, it will say error dash something something, error, Oracle error. They give you a negative number, right? And yeah, I'm going to use this. So that's one scenario that you have to handle. There are other scenarios, right, which has to do with exception handling, right? And we don't have too much time to get into that, but with every function you write, you have to assume something can go wrong. And if something can go wrong, you have to put logic to say, okay, what happens if exceptions happen? So beyond this point, you can put your exception block, right? I don't know if you remember Andy and Emmanuel, but there's a section as to how you handle exceptions. So within the exception, you could say when some scenario happens. So if we know, for example, that a scenario is, too many rows, right? Which makes sense that, a query like this shouldn't return too many rows. Too many rows is Oracle's own internal exception message to tell you that, hey, the way you wrote your function, you're expecting only one output, or one row to come back, but I'm getting too many rows. So I've seen that. What do you want to do? Right. So when that happens, you know, what are you going to tell the user? Right. So different people have different ways of dealing with it. So in this case, since we were dealing with negative numbers, you can say when this happens, and I want you to return a set of invalid codes to the user. So return let's say negative 2001. Okay. Then you put a default one. Others. The others is a catch-all, meaning that if any other exception happens during the program running, you're going to return negative 2002. Okay. Okay. So, I mean, all that this means is that you're saying that if the function runs into a problem of some sort, you put in some logic to deal with, right? So now, I mean, most programs actually, in good programming, if you go for an interview, one area they focus on is your understanding of exceptions, because the very nature of programming is that there will be errors, there will be problems. But how have you coded to handle these exceptions? Oracle has a bunch of pre-named exceptions that can happen, right? Too many rows is one of them. If you go to the documentation that we've been using, it gives you a whole bunch. There's too many rows. There is no data found. There's dupe val on index. There is value error. All kinds of things that can go wrong. It gives you these, and then it also gives you the option as a developer to actually define your own exceptions, to say that, hey, here is a scenario that if it happens, I want to give it this name. Okay. This sort of stuff will come with more practice and more experience, right? And so for the purposes of our course, the important thing is to understand the structure and to continue to practice and think of ways to do this. Honestly speaking, as a developer and as a programmer, right, your biggest challenge, right, is to pick what you've learned and to keep applying them. Okay. You have to make time to keep applying them. So, all right. With that said, I'll take a pause. And if anybody has a question, let me know. Then we'll take a quick 5-minute break. And then we'll switch on to working on the project. We spent about 30 to 45 minutes on the project. Emmanuel, you've been awfully quiet. Oh, yes, Emmanuel does not have his speaker working. So Emmanuel, if you can hear me, I'm going to dial into the bridge, and then after the break, if you have any concern or question, we can also discuss it. I do want to demo the example that Emmanuel had this problem last session. I don't know if you remember, Andy. He and I kind of worked on a solution for him. It's like a problem he had at work. So I would like to actually share the solution with you, because I think it's actually a very good test case of some of the concepts that we've learned. And I'm highlighting to him, you see the application of what we've been doing, right? So let me dial into the bridge and think about your questions, and then we will touch base in about 5 more minutes. Actually, maybe less, 5 minutes, 12:55, okay?
Please enter your PIN number.
548.
Thank you. Joining the conference now.
All right, Emmanuel, if you want to join, I've dialed into the conference bridge. So if you want to join it, the details are 718-362-6360, and the passcode is 598-5488. Okay. So you can choose to join that, and like I said, we would discuss and then switch to finishing the course. Okay. All right. We'll take a break for now, and we'll resume at 12:55. Okay. Let's mute. All righty. Let's all right. Countdown has begun. Break is almost over, guys. All right. So it's 12:55, and I would like to resume the session. Is everybody back? Please unmute your microphone and just quick roll call. Andy, are you back? Cyril?
Yes, I'm here.
Okay. Cyril? Cyril, can you hear us? Can you check in? All right. Emmanuel?
Yeah, I'm back here.
All right, cool. Emmanuel, can you check in?
Hello?
All right, cool. So, all right, I can hear Emmanuel. Let's see here. I'm gonna, since Emmanuel is, Emmanuel, since you're on, let me just,
Hello, guys. Can you still hear me, Emmanuel? All right. Can you guys hear Emmanuel?
Yes.
My screen is dark, and I don't know if it's just for me. Your screen is. Can you guys see my screen? All right. Let me stop and reshare the screen. Okay. Application window, SQL developer, share. All right. It's sharing now. Emmanuel, can you see the screen? 1 second, I can. I don't know if the kid. I stepped out for a minute. I don't know if the kid did something to it. 1 second. Okay. Well, I think you lost internet connection on your end. Yeah, it might be on my end. Sorry. Because you exited the meeting. I don't see you on the meeting anymore. Oh, you don't see me. Okay. Yeah, you're not on the meeting anymore. Oh man. I stepped out for 1 second. All right, we'll continue. Please join the meeting. I would resend the invite to you if you don't have it. Yeah, I'm joining now. Just go ahead. I'm joining now. I will. Okay. So, Cyril, Andy, do you guys have any questions from the example that I highlighted?
Yeah, not right now.
Not right now. Okay. So what I'll do is I would upload this file onto the our shared resource in the class. There's a Google folder that I have for the class, and it has you know, this function there. So I'm going to save a copy, and you know, at your own convenience, you can review it. Google Drive, SQL tutorial, and we'll call this test example function. To get average salary for the department. So that file should be uploaded in the Google shortly, and it'll be available. You know, you guys can download it because I've given you guys access to that folder. So if ever you need it, you can just go there and take a look at it, right? So, all right. So let me just put no tests with null input, and test function with common input. That's 30. Okay. Right. This is the base query used. All right. So, all too soon, this course is coming to an end, right? And as promised, I said was gonna try to see if we can apply some of these concepts that we've learned in a project. Now, admittedly, what I'd hope we could do in terms of, a project for this course, we just don't have the time to do it. And it's just the nature of, as we talked about last time, just figuring out what the needs are individually and as a team, and then figuring and just focusing on what areas that our time will be best served. So for the remainder of this course, I don't know if I really want to, I don't think it's a good idea to even do a course. I want to actually highlight that example that I was telling you about with Emmanuel, right? Where he had some data, right? And the data was structured in such a way that it was difficult for him to analyze. And he and I worked on it. And I thought it's actually a good example to show the rest of the team. So if you guys are interested, I would like to switch to that and then and discuss that with you. All right. So in my test, what did I do? I think I did it in my George schema. George schema. You guys can still see my screen, right? I feel so lonely. Nobody's talking. I understand.
Yes.
Yeah. Okay. So you might have this sort of data, right? So you find yourself, you go to these companies and you find some data that you have to work with. One of the things that you find is in terms of data storage, different teams store data differently. Some people like to store it row-wise, others want to store it column-wise. There are arguments for both sides, right? So in teams which deal with a lot of reference information, they tend to store data I would say column, sort of in a column sense. What happens is they would say, I have a job. Here he had so there's a sequence of actions that are happening. As the action starts, it records something. So the idea of it is this. If let's say in this table he has a job title and a run indicator, whether the job has started or has ended. And then he's recording the end time. Okay. Why would you design a system and store the data like this? Because presumably, most of the time it's faster to insert records into tables than to update existing records, right? Because you think of inserting a record, it's almost like, here is this data, just put it in. Like adding, I have an Excel spreadsheet and just keep adding, rows. If you have to update, you first have to identify the record you need to update, and you have to update the record itself, okay? So if the system is constantly logging or writing information, they tend to store data in this structure. This is as opposed to a table where you would have had you would have had 5 columns, right? And the column would have been job title, and it would have had something like job start time. Then actually it would have had 3 columns still, but it would have been job title, the start time, and the end time. Okay. Are you guys with me?
Yes, I am.
Okay. I'm actually concerned that I'm not hearing anything from. Okay, so Cyril and Andy, you guys are still with me. Okay. Because Emmanuel, I can hear you very loud and clear on the thing, but I think they've muted themselves. So
Yeah, I'm still here.
okay. You know what? Okay, we'll just continue. I'm highlighting this point that in the data he's dealing with, the job title is here, followed by an indicator stating that this row represents job A and it ended, and this is the time it ended. This is job A, it started and it ended. Job B, and start, right? The data is stored sort of row-wise, right? You store in each row and you're marking some indicator. And it's as opposed to, for example, like I said, a situation where maybe you had a job title followed by a column that is called the job start time, then a column that is called a job end time. So you can go to an interview and somebody will ask you, why would you rather store the data this way versus having a column that says start time versus and then the end time? And I'm explaining to you that it's faster to typically write data, like insert a new record, than to update new records. Because think about it, that if the table has 1 million records and you have to update one row, if it's indexed well, yes, it takes you some time, but it will find the right row and will update. Updating a record typically means the record layout, you have to have a history of it to say that, oh, I've gone to update the end time of job A, right? And the Oracle database has to keep a history of all of that. If you are inserting records, you just go ahead and you insert. So it's almost like, I would use the Dunkin' Donuts analogy, that if you went to Dunkin' Donuts and you ordered a product, you ordered like coffee, and then there's a queue, right? You join the queue, people are ordering, and somebody's already ordered, and then they call back, hey, I made a mistake in my order, can you fix it, right? It's already on the assembly line, right? So now let's go and locate that person's order. Hopefully it has not been filled yet, and then they can make an amendment to it, right? That's sort of when you are storing data and you are storing the column start time and end time, right? That's the scenario you run yourself into, where you have to constantly look for the record. You say, okay, job A, it started at this time, maybe 2 o'clock, okay? When the job finishes, you now have to say, hey, go and find job A in this table and update the end time to say that it ended at 6 o'clock, right? It has to go back to update the record. Now, at this point, I'm saying it can be a bit technical also to understand, but to be quite honest, if you go for an interview, somebody can give you that scenario, and you have to be able to explain yourself as I'm explaining, which is that when you have a process which is constantly just writing information, like it's just login activity, you're better off just inserting the records. Don't even insert an update. Insert an update is expensive. It takes a while, right? Because the headache or the overhead of figuring out which record to update. But if you just insert it, you don't have to worry about it. The problem is that after you've stored it this way, to make sense out of the data is very difficult, or at least to write queries. It doesn't follow the convention or the format that we are used to. But Oracle has tools for you to do that, right? So I think I sent you, Emmanuel, a proposed solution, and you made your own amendments to it, and you're able to get a result that I think made your people happy, correct?
Yes, this one.
Yes.
So okay. Thank you. But when I connected the same thing.
Emmanuel, mute the volume.
I just did.
Okay.
I just muted one.
Go for it.
So,
Yeah.
this one.
Yes.
See, the data that was given, right? Like you see where the job A, right? So the job A is going to have like each day he has a start and end. Each day he has a start and end for the whole week. So for every week he has start and end. For the whole week he start and end. When I connected and brought it into Tableau, the structure and the format kind of looks quite different. So since you brought it up, I was just going to ask if you have it for each day, like job A for each day for 7 days, start and end. Would it be the same formula that we went through it, you gave me, or it would have to be a different way?
No. So the idea of this is it's a query that you're going to run. So if, let's say, for example, and I had a query that I used to, give me a second, where did I save that? I created this table and I populated it with test data. Did I lose it? Yeah, I know. I think I know what you're referring to, which is that how do you make sure that if you have a bunch of data, how do you report on that, right? And it's okay. So it's implied. And this is what I hate about my it's not. I can't blame this. It's my fault. This thing was weighing on my mind that I should save something I was doing. And okay, where did I put this? Where did I put this?
No, so my question is that I have this data and I know that it is correct, but somehow I'm not able to prove to them that when I have done it correct.
Well, I mean, let's just take a step back, right? So we have this table. Where's my query here? Yep, and because I'm logged in as George, I can just do select stuff from EMA tests, right? And it'll give me the data. Now I can prefix as George.EMA tests just so that I'm using the fully qualified name, right? So now I'm going to put a couple of records in there. So let's say I insert into George.EMA tests values. Now I'm going to have to insert all records, so I don't have to explicitly specify the names, but generally you do something like job title. You specify the column name that you plan to put data in. Job title, followed by run indicator, okay? And then the runtime. That's one approach. Then you list the values you want to put in. Alternatively, since I want to populate all the three columns, right? Since I want to put all data in all three columns, then I don't have to specify the title. You need to specify the columns if you plan to maybe, if let's say I just wanted to do job title and the run indicator, right? Those are the only two. Then I will specify just the two, okay? But if I'm going to do all three, then I'm better off. I mean, it's shorter for me to just put all the three values in there, right? So this is just highlight a point. Now, what you're doing, right? Let me just go down and comment this. Is you have job A, right? And you're going to say start. And now this time around, you're going to do
the date is going to be different.
Yeah, so I was going to do sys select sys timestamp. Right. Let me actually get some help from SQL. It's minus 1 minute. So it says timestamp, right? If you have a column where you're storing the date and the time as well as the minutes, right? So here's like I have the date 25th January 2018. The time is 6:34:25, and I have the number of seconds. If you have a sys that's a timestamp column, right? You can use this expression this is date manipulation, right? One way is, okay, I want to subtract 1 minute from it. This is how you would do it. Interval 1 minute. And you can actually change this to hour. You can change this to day. You can even change it to, I think, week. Actually, week is not there. A day is there, right? And a month, probably a month is there. You can do year, right? So, you know, let's say for the purposes of Emmanuel, your stuff, I'm going to do hours, okay? So this expression basically says, get the current time and subtract 1 hour from it. And if I run that, it's going to say, right now it's 27 January is 1:16, and I subtract 1 from it because I'm on East Coast, it gives me 12:16, right? I could easily do plus, right? Plus 2 hours, okay? And this will take the current time stamp, and then it will add 2 hours to it. It's 1:16 on my laptop, and I add 2 hours to it. It's 3:16 in the afternoon, okay? I need to populate some data in your table, so that's why I'm doing this, right? So just to simulate what you're doing, I'm gonna do start time of 1 day, okay? And I'm gonna add a couple more rows in there. So it started and it ended, right? So ended at this time. Instead of this, I'm gonna actually do more. So I want to do maybe 18 hours, right? To kind of simulate that it took 6 hours to run, okay? Let's look at the test data to see if it makes sense. So I just added 2 more rows where 26 January, the job started at 1:16 in the afternoon and ended at 7:17 in the evening. Okay. So let's repeat that for B, okay? And instead of, so I'll make a small change here and make this 7:19, and then the start is 19. So actually 19. So this becomes, let's say 22. Right. I'm just using enough queries to populate the data, by the way, guys. So I look at this, you know, so B start, something is wrong with this math. Let me delete this guy, commit, and put the B end time again. It should be a future time. So it's B end minus 19 should really be 17. All right. If you play back this video, hopefully you understand some of the constructs I'm using here, right? It's just tricks to more SQL tricks. The more you learn it, you have different tricks. I'm just trying to highlight a job that's a 6 and ends at 8, right? And a job, right? So Emmanuel, you sort of have a lot of repeated data like this. Is that what you're saying?
Yes, that's correct.
Right.
It's a 1 week, so yes, that's correct.
So let's just use 2 days, right? You just have 2 days of data, 25th and 26th, okay, yeah. Right? We can simulate as much as we want, but we don't have enough time to finish this. So what I'm trying to highlight to you is that if you have a query that says select star from EMA tests, okay, and has this data, right?
Yeah.
What you can do, right, is to say, I want to, first get E dot star. Let me give it E. I need to get E dot star. What I can do is I can also extract out with the function extract that we're playing with. You can extract, let's say, for example, for now, let's say extract day from E dot runtime, for example. Okay. And in theory, that should just give us the day, right? So this one is just day, right? Now, if you want to kind of, you can be creative with it, right? There are different ways to extract it. one way would be for me to just simply use, just for highlighting purposes, I want to just show a couple of functions for you guys to consume later, which is you can pick the timestamp and say tochar e.runtime, and I want you to convert it into HH24, which is 24. Give me MMDB YY. I want all four. HH24 MI minute and then second. So just give me the day and time. Okay. And this structure would say something like, for all this data, extract out the day and then the time, right? This is just a formatting. There's so many. Oracle uses a lot of functions to format your data, right? So if I have any date, time, or date field, I can apply a lot of formatting to it. This is one way of doing it. And then they have extract is a relatively new option they have, which can allow you to extract certain specific components out of a date field. So this example was to extract just the day, say 25th, right, out of this whole expression. So I want to call it just the day, right? Day of events. Day of month. This is day of month. Okay. Just to complete the thought, then I can easily say extract. If I have the day of month, then maybe I can also want to extract the month from it, right? So this is day of this is event day of month. I'm gonna give it better aliases, and this is event month. Okay. And when I run this, it's going to extract out a bunch of fields. So now I have the 25th and I have the month. The last expression is using a different option to get the day and time. Okay. So, Emmanuel, I hope you see where I'm going with this, which is if you have a lot of repeated data, you may just want to focus on extracting different components out of it. So here I just want to get day of event, right? And instead of now getting the hours and the minute, I just want the day, right? So now I just want a day. So now just out of this runtime column, which is a timestamp column, I can extract a lot of fields out of it. Okay. I hope this is interesting to you guys, Cyril and Andy. I hope this is interesting. I know it's more for Emmanuel, but I do think it offers an opportunity for you to learn some of the other functions that over time, as you play with it, you come across. And once you play this video, you can always look at it.
Okay, thanks.
Right?
Yeah.
So,
George, I have a question. I mean,
go for it.
With this, can you create a table which will add columns for just the A's and then another column for B, and then we have a column for all the various columns that correspond to A and B.
So instead of creating one table with this, you want to separate them out into two?
Right. Yeah. Instead of one column, we'll have maybe column. The first column is maybe A. Second column is B, and then when you go to the next, then it holds the time, the runtime for A, and then the next one holds the runtime for B.
Yeah, the problem with that is that won't scale, right? Because the idea of it is that the job title, they have like 1 million jobs, like maybe 55, let's say 500 jobs, right?
Okay.
And so they've created a table that say, okay, the job, let's say my job is A, B, I have job A, B, C, D, E, F, all so many, right? But
Okay.
anytime the job starts, I want to record. It's almost like a customer, right? So customer A, came into the shop at this time, and customer A exited at this time. The customer can repeat, right? They can come multiple times within the same day. They can come once a week, or once, maybe multiple times within a week. But every time they come in, we record when they came in and when they exited. And maybe your job, a project like that is to say, how long do we take to fulfill our customer orders, right? When a customer comes in and we record that customer's entry, right? How long did it take for us to get out, right? So here is called a job title, but it could mean anything else. You basically recording start and end time of some activity, right? And here, in this case, the activity is a bunch of automated jobs that are running. And when the job starts, it makes an entry into the table to say, I have started, I started at this time. And when it finishes, it makes an entry to say, I've ended, right? And that's why they've structured it this way.
Okay. All right. My understanding was it was just the A and B job, A and B, and that was why I.
Right.
Yeah,
He has millions. The table has millions of records, and he's trying to figure out a way to run a query to extract out how long the job takes when it starts and when it ends.
Okay.
That's really what he's trying to work on. But unfortunately, I mean, we are used to saying that we are used to data where, let's say, I had column one, the second column was the start time, and then the third column was end time. Then you could just do, start minus end or end minus start, and then you can get how long it took to run. Unfortunately, here the data is on multiple rows. So in SQL, when you write a query, you can write functions that apply to data on the same row, but never on sort of adjacent rows, or although there are functions that can do that now with the Oracle analytic functions. We're not going to get there right now, but they have things like I think I gave you the link, Orafac, whatever it was. They have a lot of functions that can sort of approach. But for the purposes of our discussion here, just so you follow what we're doing, this is customer A, right? Let me sort this by, I've sorted it by, actually, I might be better off here. So select, order by this, and let me just order by e.job title, and ascending, followed by, and it's probably easy to just sort by the runtime descending. Okay. And when I run this, now it would say, start, end, start, end, start, end, start. Correct?
Yeah.
So I mean, Emmanuel, your case, you have a lot of data and it spans multiple weeks, multiple months, right?
Yeah, so for every job, it was recorded. So one job for 1 week, it will record, it will run 7 times. And then the next week, for that same job, it will run another 7 times. And I have 4 jobs going on. So 4 times 7 was going to be 36 for each week. There was only 36 rows for each week. So it was running. That's how it was running. So for each job, it was running for 7 days.
Yeah, I mean, yeah. So if 7 days in a week, and you're saying that every day it runs 2 times, right? So you get 4 rows per day. That's what you're saying. So about 28 rows in total, right?
Yeah, that's correct. Yes.
Yeah, which is fine. I mean, it's the point of it is, your objective in that case is to think of the problem this way. If a job can run multiple times within a day, then it's not enough for you to, one of the fields you need to have is the day itself and the start time, right? Because within a day, if something can run multiple, like a customer goes to a shop 2 times a day, you need to uniquely identify each time they came in. So they came in at 10 a.m. and left at 11 a.m. Then they came in again at 5 p.m. and left at 7 p.m. 2 separate events that happened. The first case, they spent 1 hour. The second case, they spent 2 hours. But if I'm describing that to somebody, they need to know that this customer came in on January 26th at 10 a.m. and left at 11 a.m. on January 26th. Then they came back in the same January 26th at 5 p.m. and left at 7 p.m., right? You need to have both the date and the initial start time to uniquely help you identify sort of each of these transactions or activities that happened, right? So that's why I was just trying to show you these sort of ways to extract the various components. right? In your case, since you're going to have multiple things, you definitely need to have, in my opinion, this one, right? This one, the date and the start time, you need to have them. However, for the purposes of the analysis that you were doing, right? And this is the main thing I was trying to explain in this thing to them is you have the data on multiple rows. So here you see that, look at the first two rows, right? The job started at 1:16 p.m. and it ended at 7 p.m. Visually looking at this, you know it took about 6 hours. But how do you write a SQL to get the 6 hours?
Yeah.
Right? And that's why I said you have to do a self-join, right? I mean, I have the final solution here, so I can sort of walk you through it. But the point is that you need to do a self-join to help you extract out the start records into a separate table, and then to extract out the end records into a separate sort of temporary table. So for example, here you can say where e.run indicator is equal to start, right? Then it will only have the start records, right? Now only has the start records. Then you can sort of have a separate set where you have the end records, right?
So that was my point. So I was only seeing the start, and so in that case, is the where going to express to saying where this is end, and then where if you want to see two, if you want to see both of them, how do you expose both of them? Right.
So I mean, I won't go through the solution, but let me just type it again so that maybe you can follow along. So what I was saying to you is that you have to do a scenario like this. You have to sort of join the table back to itself so that it can sort of pivot the data, so that data that is relevant to the same date and time, you can keep it on that same record, right? Same row. Now, the problem that, when you described it to me, we were looking at, one, it was, the job was running once in a day, right? That was the scenario that we worked with. I gave the sample data I was looking at. It was just for any given dates, you're getting one, one activity. So the assumption was the customer comes in once a day, right? But if the customer, go ahead.
Yeah, for a day, it's going to be one for each day, but for every day for a week.
Right, but what if the customer comes in multiple times in what if the customer comes in multiple times in a day, right? Your query should be able to handle that. Guys, can you hold on 1 second? It's downstairs.
Okay.
Let me finish it now.
Go forget my glasses. Let's do it. Okay.
Apologies for that. And these kids, I told them 1:30, and they are just literally at my door at 1:30. Sorry about that. Yeah, I just want to just look at the base case, right? So, which is, if I run this query on top, right? In the interest of time, let me just look at the solution I gave you. So it's the same table, EMA test, and I'm rejoining it to itself, which is the self join. And the idea of it is you're going to say, in the case where for the A table, let's just get the start records. And for the B table, let's get the end records, right? And if you do it that way, you're going to get something like this, right? Okay?
Yeah.
So
Yeah, correct.
you see how you're getting the numbers all kind of funky all over the place?
Yeah.
Right? The reason is that when you and I were doing it, it was once per day. So if you now are saying that you can have multiple, within the same day, the customer or the job can run multiple times in a day, then you need to then enrich your output, right? The filters, so that you are handling correctly the case where the customer can come in or the job can run multiple times in a day, right? So I'll do something very quickly and clean up the data so that you just see the case where the job was running once a day. And then I'll run the query, and then we'll see the report. Now, let's see, can I have the time to finish? All right, hold on. Let's start. And start. And actually, yeah, I just have to add the filter here, but let me. Delete. Only fit the records. Start. I need to delete more start. And then I have to go here and delete this, delete that, and connect. Okay. So here's just two cases where we have data for job A, it ran on this day, and then job B. I come here and I run this query, right? You see that it's effectively transformed the 4 rows that we have here. It's now transformed them into 2 rows. And the transformation was basically to then make this, okay, I have the start time and an end time because I use the alias for it, right?
Yes, I get it.
And then with each one, it's now able to tell us how many seconds it took to run. Okay. Now the formula to get the seconds it takes to run, you and I talked about it, where I said there are 24 hours in a day. To get the number of seconds, you need to multiply by 60 minutes by hours, and then within the hour you have to multiply by that. So this effectively is 1440, which is this is 86400.
Yeah, that's one.
Yeah.
Even that one, I'm not interested anymore.
Okay.
Yeah, so for the sake of time, I know you have to go. So.
Right. So. Yeah, I was just trying to explain something quickly for the playback, right? So if somebody goes in and say, okay, why am I multiplying by this? Is because when you get the day, you want to convert the day into seconds. And so basically, if you don't want to do it this way, which is 24 hours times within an hour, 60 minutes, and within an hour, 60 minutes, and within a minute, 60 seconds, right? 24 by 60, right? And if you have an hour and you want to convert, if I have 1 hour, how many seconds that is? It's within an hour, you have 60 minutes. Within the 60 minutes, within a minute, you have 60 seconds, right? So that's that expression. If you have a minute and you want to convert it into seconds, you multiply by 60. So, and then you extract the second out of it. So whatever this expression is, if you add the days in seconds, the hours in seconds, the minutes in seconds, and then the second in whatever, you just get the second out of it, and you sum it together, then you get the total, the difference, the time it took, everything in seconds, right? If you only want it in minutes, you can take out the 60 across the board, right? And get rid of this last row. The point is, if you're not, you said you're not interested in this piece anymore, right, Emmanuel?
Yes, that's correct.
Okay. Yes. So what you're focused on is now, how do we deal with a scenario where you have multiple, the job can run multiple times in a day or multiple times within a week, correct?
Yes, multiple times within a week, yes.
Yeah, which is, yeah. So irrespective of when it runs, we need to handle how it would do this stuff. So let me insert some data back into this thing. Let me just insert the records back in. The start is more. Let's see.
Because I sent you how the data is coming out in Tableau, and I'm looking at it. I see one start date from the 20th and another start date on the 9th, end date on the 19th. And I'm wondering why. I think the data is wrong. I'm wondering why it's starting at 20th and ending on the.
No, and that's because that's the fundamental point about self-join, right? If you're going to do self-joins, you need to understand what it's going to give you. Right, let me look at the data. Okay, so I got my 4 rows back in. Okay, I give you this time. So let's take it step by step. So we have, and guys, if you need to leave, you can leave. Right? If you don't have to stay on. I'm just, Emmanuel and I need to talk about this a bit. So, but if you're interested, please feel free to stay. Right? The way we do self joins from our queries is you have the same table, right? Let me give it here. I'm going to call it A, and here I'm going to call it B. Okay. Okay. Here's A, and here I'm going to call it B. Okay. So I can do this. Okay. Now join. Okay. On A dot. The assumption, and this is the key part. The assumption at that time was just the job title was going to be enough, right? So A dot job title, because of the data that we're working with, is equal to B dot job title. So in a baseline scenario, when you just run this query, right? Right, you say, okay, I'm joining this table to itself on the fact that if the job title is the same, then I want you to show everything on the same line. So if you just run this, it would transform your data to about 32 rows, right? 8 times 4. But that's not what you want. You basically want to start applying some filters. The first thing you do is just, okay, all right, on the A record, on the A, I just want you to just give me the run indicator where it's equal to just the start. Just give me the start records from A, and then the B, just give me the end records. This is data transformation that's going on here. So once you put the where clause to kind of help with the transformation, we say, all right, now where are we? What is this giving us? Okay, so I'm still back to my 8 rows. But what it says is this is the start, and this is the end. But it's kind of, how do I know that this is actually correct? I mean, how do I know this is the actual start and that it ended at this time, right? This here is saying that 26th January, and it just doesn't make sense. And why it doesn't make sense is that you're only joining on the job title. So if it is the case that you need to know the order of the order in which your data, like the execution and all that stuff, then you may say, well, whilst this is giving me the start and the end records in 2 separate tables, and I'm sort of self-joining, the question is, I may need to add one more join condition here, which would say something to the effect that, and this part is not very simple because you have to really study your data to get a sense of it. The first assumption, or the first guide, or at least I would provide, is you say, well, in general, looking at this data, right, you have the job and the end, the job and the end. If I need to know if these two are together, right, how do I know these 2 rows are together? I mean, nothing is telling me that this is together or that's together. Now, there's another way to do this, which I won't go about, but you use something called the row ID. But that's a separate argument, and I don't want to get into that right now. But it's very important here, the order of the data is very important to you. So you need to figure out a way to source the data, right? Okay. Now, since we know that when we order data, right? When we order data, the order by is applied at the very end. Okay, the order by is applied at the very end. Then we need to figure out a way to order our results intermediately. So one thing that you could do is to say, I mean, then the solution actually becomes a little different. So you probably have to say select star from IMA test where run indicator wait, are you saying the job is running once a day?
Yeah, it's running once a day, but so each day for 1 week.
Okay,
so
if it's running once a day, then we actually can handle it a little better here and just say basically we would say something to the effect, but it's a problem. This solution is a problem. You'd say remember the extract stuff we're doing? You basically don't have to say when you extract out the day from a.runtime, okay, it will have to match the extract of this b.runtime, meaning the job runs when the job runs within a day, it ends within the same day. I find that as problematic as a solution. What if the job starts at midnight and ends the following day?
That's what that's the time it starts. It starts at midnight, and so some days it can trip.
No. So typically, most of these jobs, right? Let's say the time now is 11:30 p.m. and you start some process, and the process runs for 45 minutes. That means that the job is actually going to end at 12:15 a.m. the next day. So if you are going to say the day, this expression means the day has to match, you have a problem, right? Because it doesn't. In this case, you will miss that what you call that. You will miss the entries.
Yeah. So should we do it the hours?
No, I mean that won't still solve your problem, right? I mean,
George,
I want you to understand it.
I have a question here.
Yeah, Andy, go for it.
Yeah, is it like I mean, using the customer situation when you explain with the customer going into a shop, let's assume a customer has an account number, right?
Yeah.
Is it possible that there could be, I mean, I'm asking Emmanuel, is it possible that each feed from each particular job title has a unique number or something besides showing the start and the end date?
Andy, I didn't get you. Without showing the what?
I mean, besides the start and then end or the job title as A, can we say that whichever feed, I mean, where the feed is coming from, whichever, if it's the customer could have like a customer account number, right? So, and the customer comes in, that's the start, goes out, that's the end, right? So if the customer has an account number, we can associate that. I don't know if I'm saying the right. Oh, George, does it make sense? We can say that it has a unique.
It doesn't. Just from what you were saying, actually makes sense to me. But so that's where we have to find a way of like solving it. So now, if a job starts at midnight and runs into another time, another day, then the day formula that we are using will be problematic, like you said. That makes sense to me more.
Well, I mean, it's so let's take a step back, right? What you're trying to solve here is, and I think I know where Andy you are going with it is, okay, you have a problem where you cannot uniquely sort of tag that, okay, this job started at this value, right? at maybe 8 o'clock, and it ended at 10 o'clock. How does the 10 o'clock end record know that it's actually tagged with the start time of 8 o'clock?
Right, exactly, yeah.
And you don't.
Yeah.
So typically you would resort to a couple of solutions. Either you sort the data, right? Because your assumption is that the data is going to be sorted. I mean, the entries are always going to be made in a sequential manner, right? So if the moment you started this process, if I insert a record at January 1st, 1 a.m. as a start, then the next end time would have to, by the definition, right, would have to end after 1 a.m. on January 1st, right? So one definite solution is to sort your data, right? If you're doing it in Excel, you probably do something like that, where you would sort all your data and then subtract the next sort of two adjacent rows, right? The runtime, and say that, okay, on this screen, basically the difference between these two gives me that. The difference between these two, this give me that, right? The problem with that is, okay, now you have job title, and you have, if you have multiple jobs, how do you assure or guarantee yourself of that? And the proposal I was trying to give was, okay, how do we uniquely tag each start time with an end time? And so one approach is you say, well, if the job starts on a day and ends within the same day, and it's only running once a day, then this would work. Because here you see that when I ran it, it said 25th January at 2 a.m. It ended at 9 a.m. on the same day, right? And that's for job title B, right? The problem, again, is here the assumption is you're only dealing with that you're using the day to say, oh, this job only runs once a day, and when it starts, it then never spills over to the next day. Because if it ever spills over, then this situation becomes problematic, right? Because then if, let's say, your job started at, like I was giving the example, 11:30, right? And then they finish at 11:30 p.m. and they finish at 15 minutes after midnight, right? Then the day components will change, right? It wouldn't match. So then so that record won't show up here, right? It won't, because there won't be, that join won't work. So those records will be excluded, which is not what you want.
So what would be the best solution?
Okay, I just saw the picture you sent me. What's that? So that's your.
No. Yeah. So let's do this first. The picture. So when I did it, when I applied your query and used that picture and used the data, now when I went into Tableau and I brought the data, tried to pull the data fresh to face, like to compare.
Oh, okay, I see what you're saying.
Now.
Finish your thought there. Emmanuel, go ahead, please. Sorry, I interrupted you.
Yeah, so what I'm seeing that the runtime, one of the runtime, the numbers are not consistent, because how can it run on this January 20th and then end on January 19th?
Yeah, and it works just by definition, because the query I gave you was assuming that you didn't care about. Right? But now what I'm saying to you is, if you make one enhancement you can do to it is, you have to add this extra join, right, to it to say that, well, if a job starts, it ends the same day, so let's add the day as a criteria. Now, if you're not, you're saying, oh, well, if that's the case, then I have a problem. Then you have to say, okay, well, how else can I guarantee that if the job runs into the next day, I won't have an issue? So it's all sort of mathematical, right? So you can say something like, if my end, and I'm not writing SQL code, right? If my end time minus my start time exceeds 80s, because if your job is running once a day, right, then basically by definition you're saying, okay, the job every day is starting at a specific time. I don't know. Let's not make that even an assumption, because these automated systems, they have dependencies, right? So maybe I have a job and that job has to wait for 10 conditions to be successful before it starts. So you can never say it was going to start as a fixed time. But one criteria you have to use is the difference between my start and end time cannot exceed a certain value, right? Now, I'm not saying that's a solution, but I'm just trying to get your mind to think along the lines of how you solve the problem. Is okay. The difference between my and can maybe it has to be strictly less than, for the sake of argument, it's strictly less than 86,400 seconds, which is 1 day, right? No job can run for more than that period. All right. So this is the first boundary condition that you put in. Okay. So what's the next one? How about yeah? Just trying to try something.
Are you asking a question?
No, I was going to say, like, so whilst I have this condition, I may say that if I run this output and it gives me some result, apply an extra, make an inner query around it, and then isolate out my bad records, right? Knowing that, this is the case. So, actually, this particular expression won't solve our problem, because if the job runs on different days, then this won't work. So what we have to find out is that if I look at the start time and I add, how about this? No, actually, that's a problem. That's a problem. That won't work. That won't work. Okay, I scheduled this meeting to cut off at 2 o'clock. So I know Google is going to probably end this thing very soon. So here's what I'll work with you guys on. I'm gonna, with the clarification Emmanuel you've given, I'm going to try to work on a solution, and then I'll send it as a separate link, right? Once I find a solution, I'll put it together. I'll record a video, give a solution, and you guys can look at it as sort of bonus material, okay? But the key takeaway is dealing with data in this format, right? Where the job title is not enough. You need to maybe use a day as an extra filter, because right now in this particular case, this is actually fine. What I'm showing you, it's fine, but it's limited by the fact that if a job starts and ends the next day, then it won't show up here, because this rule or this line basically requires that if today's the 25th and the job started, then the end also has to be 25. So if the job started on the 25th and it ended on the next day, 26th, then those records will be excluded in our output. And that's the problem, because those records would not be part of this. Now one way you do it is, sometimes the way I'll do it, I'll do something like this, and I'll say, give me this data. And then once that is done, I'm going to have a separate query that will identify only those records where the time goes past the next day. So it will be something like, if I extract the day, right? If I get the runtime, I'm only going to look for cases where the day, it will be something like this. The start time minus this is equal to -1, which is, I have a job that started, but if the 25th is the day here, and this is the 26th, then the difference is 1 day, right? So it'll be 25 minus 26, which is -1. This will give me records of jobs which started the day prior, right? So then I will treat those as a separate query. like using like a union or something, where I would say, okay, now let me go extract out these records. Okay, this doesn't cut off the recording. I would say select this start and I need you to extract out cases where this is true, right? This piece of it will give me jobs where the start day is at least it's 1 day less than the end day, meaning jobs start and then end on the next day. Okay, that's one solution. For me, if I'm solving a problem and I have to have certain cases like this, the thought process that comes to my mind is, nah, I'm doing something wrong. Because what happens if the job ends up running for 2 days or 3 days or 4 days or 5 days? Then you're like, okay, I have to do more unions. Something is wrong if you start solving a problem this way. But if the requirement from the business explicitly tells you that the most a job can run is no more than
2 hours.
If say the most a job can run is no more than 1 day, right? As in, if a job starts on Monday, there's no way it will end on Wednesday. Then I'm comfortable with you saying, okay, then I just know there's only one more case, so that I can handle it in this particular scenario, right?
Yeah.
Because this is a case where when you run this this condition here, they put it here. I mean, this wouldn't return anything because I don't think I have that scenario in this data. But actually, hold on. Where my runtime, my start is equal to -1. Actually, yeah, I do have cases like that where the job started, it started at 2, it ended the next day, right? So, yep. All right. I'm going to end the session, and then I'm going to work on a solution that makes the most sense, and then I'll give it to Emmanuel. But the takeaway I wanted to show really Andy and Cyril was that if your data was set up in this form where you only had, okay, A, right, you could use a self-join to transform your data to get them into columns, right? Because here you have the job title, the run indicator, and the runtime. And the objective was to transform this to get job title, start time, and the end time, right? And you can use a self-join to do that. But obviously, with that approach, you then have to now figure out what are the join clauses that you have to use to guarantee that the start time you get corresponds to the end time. Andy, you're right to say that in a very good system, and Emmanuel, you may have to explore your data a bit better. Because I know the table that you're dealing with, right? You give me a little picture. You were explicitly filtering the columns you wanted. You're saying select table dots that. You may actually have to investigate the table. There might be a column which is unique. Because in these systems, right, what happens is that when a job starts, like the customer example that Andy was using, it would have said that there's this unique ID that identifies this particular transaction. So each record, yes. So if you need to have a transaction ID that you uniquely identify, because if you can never store data in a very good way if you just have these 3 columns. So there has to be, you and I can talk offline about this. There has to be another column that tells you that job A starting, right? They had a particular transaction ID that they recorded, and when they ended, they put the same transaction ID. So without a doubt, yeah.
Yes. So what the data says is that every ID, every job, when every job starts, the start ID for every job is 91. And then when it ends, it's 96 for every job. So there's a column that has 1 and 96, which says 1 means start and 96 means end.
Well, but that for me, that plays the same role as end and start. What I'm saying is that if you go to a store multiple times, every time you buy something, they give you a transaction ID, right?
Yes, that's correct.
You need that. That is what is missing here to really make this data, in my mind, set up correctly, right? Even though we can still come up with a solution if that information is not there, I need you to, when I call, I need you, after I'll call you, I need you to investigate, because I want you to just do select maybe, the alias dot star, right? And show me the first few columns, because I have to think a system like that has that when the job starts, it gives, say, okay, job A has started today, right? That's a job title. This is the end. This is the runtime. But it will have something there that says this is a record of its transaction, right? That would link. It would link two adjacent rows to say that these two rows have to be treated together. If that's not the case, then you are left with very little option than to go in a very expensive route. Okay, Emmanuel left, so you're left with this approach where you have to explicitly order the results and process the results. So you'd have to order by first of all a dot job title, and then you have to do Manuel dropped off, so I'm gonna put him on mute. Take it off speaker. You have to do a dot runtime. Okay. Sending. That this way you would is it runtime or one was runtime one word? It's run underscore time. Right? Oh, I didn't give it an alias yet. Yeah. This approach is guaranteed that the data now is ordered. Okay. So for the given job, you've sorted it by this, and you're going to make that assumption that they've done it well. Now, this is where Andy and Cyril, this is where it makes a lot of sense to create a function, right? And the function would be responsible to say, it will pick the first two adjacent rows, and it will check that the first row is start, the second row is end. And if this condition is true, then it will give you the difference of these two, right? Okay. You have to you can create a function to do what Emmanuel really wants to do here. Yeah. Because this assumption of sorting the data, even if you sort it and you are trying to work with it, the problem you have is, what if this is start and this is also start? So you need to have a way of checking the two adjacent rows. The first one is start and the second one is end. Now time is far spent, so I'm going to wrap this up. And as I promised, I'm going to work on a solution and then post another video and share the solution with you guys.
Okay.
Okay.
All right.
So that wraps it up for this intermediate SQL course. Now, I will leave it up to you guys to figure out what else, what you want to do after this. Now, what I would recommend is maybe the next, if you guys are interested, I'll create a session where it will be half, maybe I'll say 30% SQL and 70% scripting. When I say scripting, either PowerShell, Python, or whatever language you guys are interested in. Okay. I'll most likely lean towards using Python because I think that's a much more marketable skill to have. Okay. That's if you guys are interested. So if you guys are interested and you want to reach out, that's fine. It doesn't have to be all parties have to be interested, right? So if Andy, for example, is interested in something and he wants to, fine, we can open it up. If Cyril is interested in something, we can open it up. I think there's a couple of students who seem interested in actually taking a course where I'll take them through. I don't recommend it for Andy at all. Cyril probably could benefit from it, to be quite honest, but it would be sort of an introductory to concepts about, programming or computing, right? Which is Excel analysis to learning sort of the basic infrastructure behind computers and how they interface with, before you even start learning SQL or before you even start learning some of these other third or fourth generation languages, right? I'm in the process of trying to put that one together. If I get commitment from the parties, I'll let you guys know if you're interested. So let me know if you guys want to talk about that now, or if the next steps here now, or you want to do it later on. Through the we can just email or chat or have a separate session to discuss it.
Okay. I think time is well spent. What we'll do is we'll discuss it among us, and then we'll maybe let you know, have a conference call or something, and then we'll see what the direction will be.
Right.
Yeah.
And please, in the meantime, send me your resumes.
Okay.
Because I think you guys know enough, in my humble opinion, that if you just went through a set of interview questions, maybe about 20 or 30 of them that you polish up on, and you kept practicing, you should do very well at the interviews. Because most SQL jobs, quite frankly, guys, are not as complicated in terms of, you really just have to get the job and then get the project, and then like I said, we can talk about an arrangement where I can help you do a very good job at it, right?
Okay.
So, all right, guys.
All right. Thank you very much.
All right. Thank you, Emmanuel.
Yes, I don't know if everybody has. When I first had this solution and I did it and it worked, I was so excited. And when my boss asked me if I was going to be able to do it, I said yes. So he said, okay, then I'll leave it to you. I'm not calling anybody. And my work is actually due on Tuesday, I think. Tuesday. And I said yes, I got it all together. So nobody's needed. And now, I'm finding all these problems with it. So I'm just begging of you or asking if how fast can you get to me so that I can do that before I even put it into Tableau?
No, to be quite honest, the clarification you've given to the problem, I'm going to make a small tweak to it and hopefully give you a response by tomorrow, realistically, because I need to just step out of the house with the boys, and I promised them. So when I go, I'll come back maybe tonight, but I'll try to wake up early in the morning tomorrow and then spend some time on it and reach out to you. Once I have the solution, like I said, I will make a recording of it and I'll send it to you guys. But just to be clear, basically you want the data you've said is you have the start and the end time, the job title, right? And no job can run for more than 24 hours, right? And that's sort of the data you're working with, correct?
Yes, that's
okay.
Correct, yes.
That's fine. So, I already have a solution in mind, but it would take another 30 to 45 minutes to kind of work it out and find a solution. And I don't want to waste anybody's time and sort of going through that thought process. Time will, I don't think will serve anybody's interest right now. So let me take it offline, work out a solution, and I'll get back to you guys with a video presentation.
Because I got all the praises on Friday, and then only to put it together on Tableau, and I'm finding all this problems. So yes, thank you so much, and I will wait for you.
All right, cool. All right, guys.
Thank you, guys.
All right.
Okay, thank you.
All right. Thank you very much. Yeah.